All right, guys, welcome again. And in this chapter, we are going to talk about comments, variables, and constants. Right, so what we will learn again, obviously, comments, variable types, constants and immutable variables, and variable scope. Cool, so let's just get started with comments here. Live code, let's go back to Remix. If you have been coding for a while, there is not much to discuss here, and you know that comments are necessary to explain the code, or sometimes it is necessary to explain the code. If you have not been coding for a while, just remember this. We don't write programs for the computer. If we did, we could just write the code in bytecode. We write it for ourselves and other people, other developers. A code that is hard to understand is not shareable and obfuscates the logic, and it's not really that useful. Actually, you yourself might be hard pressed to understand your own code a couple of months from now if you cannot understand or if you don't write it in a way that it's easy to understand. Comments can sometimes help. I mean, there's obviously a thing called too much comment. So there is this line, a fine line, but comments can help. You have already been using comments like here before, like slashes, that was a comment. This is a comment. And if you have used JavaScript before, this would look familiar because that's how you write a comment in JavaScript. But these are like single line comments. You can actually also add multiple line comments by using this notation. And just start with this and say, this is a comment. Here's another line of the comment, and then you can close off the comments by using this again. So in Solidity, it's possible to write single line comments like this and multiple line comments like this. So the next thing we're going to tackle is, let's go back here. The next thing we're going to tackle is the variable types. We have already discussed multiple times how Solidity is a statically typed language. What that means is that you have to declare the type of the variable before you can assign a value to it. Contrast that with JavaScript, which is a loosely typed language, where you don't have to specify the type of information that will be stored in the variable in advance. Here's an example contrasting JavaScript and Solidity. In JavaScript, you just write var myString equals hello world, and you don't have to specify that this string is actually of the type string. In Solidity, on the other hand, you have to specify here string myString is code is law, and yeah. So that is the difference between JavaScript and Solidity. Cool. Let's look at a few commonly used types in Solidity and how we can declare them. This code actually does not have a good syntax highlighting, so we'll just copy paste this in Remix and see how it looks. In Solidity, we already saw that we actually have to type out the word string before myString if we're going to assign a string to this value. Similarly, there is another type called Boolean, which is true or false. You can just write the type bool, which is the Boolean type. So let's start writing here. So this is the string type. Here's the Boolean type, bool, and then we see int, which is the integer type, and then we also have, which is the unsigned integer. Unassigned, that's not right. It's unsigned integers. The difference between int and uint is that this uint type cannot have any signs. So it will always be positive. This negative is a sign. Although you can have that in int type, you cannot have that unsigned integer types. So that is the difference. And moreover, another thing to note here is uint is actually short for uint 256. What that really means is you can hold 256 bits of information in this variable. How much is 256 bit of information, you ask? So it's 2 over 256. So your integer can be this big. But uint 256 is not the only type of unsigned or signed integer out there. You can, sorry, go back here. You can actually specify a lesser unsigned integer value type, which could be uint 8 or uint 16 or uint 32. And you can always calculate the biggest unsigned value that could be assigned to it through this formula, like this 2 to the power 256 gives you that. You can actually go to 2 to the power 8, and that can hold values up to 256. Yes, so that's int and unassigned integer. Int also can do everything that we talked about in unsigned integer. Int also stands for int 256, and we can assign int 8, int 16, and int 32, and so forth. So all this is possible with int and unsigned integer. To read more about these things, you can always go to the docs. I know that reading docs is not fun, but yeah, I mean, you have to get used to it. And go to the value types, click on integer, look at all of this, the booleans and other types as well. Okay, coming back to our code, we have another type which is known as the address type, and you can use this, like you can say address constant wrapped Ethereum is this. That's the address of wrapped Ethereum. That's another type which we will use frequently in our class. So I just wanted to introduce that to you guys. Then you can retrieve it. You can write a getter function around it. You can return an address. That's the type as well of this. If you're going to return with constant. And this is it, guys. That's it for variable types. Now, if you look at this, like constant, what is this constant thing? That actually is the next topic of discussion. Constants and immutable types. In Solidity, state variables can be declared as constants or immutable. In both cases, the variables cannot be modified after the contract has been constructed. For constant variables, value is fixed at the compile time. When this code was being compiled, with got a value assigned here, and that is it. It cannot change after that. An example would be event, that was an address example. You can have example in any type. So it's event constant Sean, and we wrote this expression which will get assigned to this during the compilation time, and that is it. Another thing to remember is that constants really do not have access to storage values or anything related to blockchain. Any blockchain data you cannot put in a constant at the compile time. Like if you do this constant who is address this is not allowed because this is a blockchain data. You cannot put it in here. The workaround around this is using the immutable variables, which is like constants, but they are less restrictive. Let's walk through an example here. Again, in this example, there is no syntax highlighting here, so I'm going to copy paste it in Remix to look at it in a better way. So here we have a constant immute example, and we have two constants that we assigned at the top of our contract. The constant sample, which is hello world, and then constant my hash, which we said Kechak 256 Cody. So Kechak 256 is actually calling outside this contract. So technically it should not be allowed, but this is the only time, the only exception to the rule. Kechak 256 function calls are allowed for constants. Anything else that calls outside the contract, calls for the state value or calls for blockchain data is not allowed. So another one is constant Sean. We already looked at this example before. This is also allowed because this is not really looking at any blockchain data. Then there's this immutable, sum number and well balance. And you can see we use these sum number and well balance and we assign them inside a constructor. If they were constant, they would not have been allowed to be changed inside the constructor. Constants can only change during the compilation time, but immutable can change once when this entire contract is being constructed. We can even assign the value like this, message to sender. Again, immutable can have access to blockchain data and Solidity constants like message.sender, message.value. Constants don't really have that flexibility. So that is the difference between constants and immutable variables. All right, so the next topic of discussion is variable scope. So there are two kinds of variable scopes in Solidity. One is the state scope and one other is the local scope. So state variables, the variables with state scopes, are those variables whose values are permanently stored in storage. Note that the word state here actually means the state of the blockchain. That's what it's referring to. And then there's local variable, which are not really stored in any blockchain state. They are defined inside functions and they're kept in stack memory location. So you initiate these variables inside the functions, and when the functions are done executing, they do not exist anymore. They disappear. They're temporary variables. We can look at an example here. Let's look at this example. Again, because of syntax highlighting, I'm gonna go and paste it in Remix, see how it looks. This is for scope. So we have already covered this. A variable that is outside the function but inside the contract is a state variable. This is a state variable, and this variable will always be stored as a blockchain state. So you can always change the state variable because it's not const in the constructor function, and that's that. And then there is another variable, you can touch me. That is a local variable. This variable is initiated inside this function get result, and once this function stops executing, you will not have access to this variable. This variable is temporary, and that is the difference between state variable and local variable. And that is it for this chapter. I'll see you in the next.